Hi, I'm Ellie Pinchers, an Education Officer here at the Royal Meteorological Society. In this series of short films, we're going to be covering some of the background information that teachers may find useful if they're teaching weather and climate at secondary level, and specifically if they're using our Weather and Climate teaching guide with the accompanying classroom resources, which can be found on our website, MetLink. There's links in the text below. In this film, we're going to look at current UK climate change. The climate of the UK has always changed. Over past decades, it has been getting warmer and the number of extreme rainfall events has been increasing. We expect the climate to continue to change as a result of global past, current and future greenhouse gas emissions. The 21st century will bring warmer, drier summers and milder, wetter winters to the UK. The number of extreme weather events and their severity will increase. Flood risks from sea level rise and extreme rainfall events are a significant concern, as well as the potential for water shortages. Although there remains uncertainty in projections, the data is unequivocal, and although the effects will vary, it is certain that our daily lives, our landscape and our flora and fauna will face significant change in the next 80 years and beyond. The Central England Temperature Record dataset is the longest instrumental record of temperature in the world. The data represents the temperature in a roughly triangular area of the United Kingdom, enclosed by Lancashire, London and Bristol. The sources of data include records kept by individuals around the country, all carefully combined and corrected for factors such as changing instruments over time. The precision of the data published for each year reflects the number, accuracy, reliability and geographical spread of the temperature records that were available for that year. So early in the record, the data may only have a precision of 1 or half a degree Celsius, whereas more recent data has a precision of about 0.1 degrees Celsius. The mean monthly temperature record starts in 1659, with the daily data being available from 772, and maximum and minimum temperatures and monthly data beginning in 1878. The full data set can be found in the link below. The magnitude, effects and impacts of global climate change are modelled and published by the Intergovernmental Panel on Climate Change, or the IPCC, a body created by the World Meteorological Organization and the United Nations Environment Programme in 1988 that synthesised the peer-reviewed inputs of thousands of climate scientists into a series of reports published every 6 to 9 years. Due to the magnitude and regional variation in forecast risks, national meteorological organisations run localised models that provide higher accuracy forecasts for their local areas. In the UK, the body that completes this work is the Met Office. The Met Office publishes an annual State of the UK Climate Report. It summarises current weather and climate in the context of the past, as well as the UK climate projections, which provide the most up-to-date assessment of how the UK climate will change over the next 21st century. Over the next 21st century, the climate will have warmer, wetter winters and hotter, drier summers. However, within this broad statement lies significant spatial variation and uncertainty as to the exact magnitude of these changes. Some of the uncertainty in projections of the future are due to not knowing how the world will develop. How will population change? How will our distribution change? And how will countries develop economically? How will we change our emissions? All of these factors will have an impact on greenhouse gas emissions and consequently on climate change on both a global and regional scale. In addition, we do not know how the natural climate forcing mechanisms such as volcanic eruptions and the behaviour of the sun will change, and there are also some parts of the climate system which are relatively poorly understood. As a result, some important elements of climate, such as clouds, are not well represented in the climate models. All these factors are taken into account in the vast computer models used to make climate projections, giving us an ensemble or group of forecasts from which a probabilistic-based prediction is made. This tells us what changes are most likely. Within a climate projection, the smaller the area scale, or the shorter the timescale you want to know about, the greater the uncertainty. It is much easier to make a prediction for 2050 to 2100 climate for the Northern Hemisphere, for example, than it is for Birmingham in 2060. However, it is this kind of detailed information that planners need. As the climate warms, it will have a number of direct and indirect impacts on the environment, the biosphere and people in the UK. For the weather to constitute a heatwave, it has to be unusually hot for a sustained period of time. When do we get heatwaves in the UK? Tropical continental air can bring warm, sunny weather, but it's actually anticyclones or high pressure systems that give us heat waves. In an anticyclone, the air is sinking. As it sinks, the pressure of the air rises and it gets warmer, so any cloud droplets evaporate and lead to clear skies. In summer, this means that the sun's light warms the ground, which in turn warms the air above. Anticyclones tend to last a relatively long time, so the ground and therefore the air above can really heat up. Without any clouds, there's very little chance of any rainfall. A UK heatwave is defined by the Met Office as a period of at least 3 days when the temperature is higher than the regional temperature threshold. If summer temperatures are usually quite high in a place, it has to get even hotter to count as a heatwave. So if you're based in a region in the south of the UK, the average summer temperatures where you live are higher than the Scottish Highlands, and therefore the threshold for a heatwave is higher too. This map shows the heatwave threshold for the UK. Note the regional differences, with the threshold being about 28 degrees Celsius around London, but only 25 degrees Celsius for Scotland and much of Wales, Northern England and the South West. As the climate warms, all weather types can still occur, but extremely cold weather happens less frequently and extremely warm weather happens more frequently. Weather that was unusually warm before becomes normal or more likely. So the Met Office has had to change its definition of a heat wave. If a heat wave is when the temperature is warmer than normal for that place, if the normal changes, so does the definition of a heat wave. This map shows the heatwave threshold from 1961 to 1990 with the same colour key as the previous map. You'll notice it's quite different. The hot weather that we experience during a heatwave can lead to serious health issues for people and plants and animals. We'll go into this in more detail in chapter 16, which is a chapter all about anticyclones. In 2022, the UK experienced 3 short heat waves. In mid-July, some parts of the UK saw temperatures reach over 40 degrees Celsius for the first time in recorded history. The highest temperature was actually 40.3 degrees Celsius in Coningsby in Lincolnshire. This was a huge 1.6 degrees above the previous highest record temperature for the UK, a record set in 2019. Scotland also had its highest temperature, with 34.8 degrees recorded at Chatterall. Temperatures were between 2 degrees and 4 degrees warmer than they would have been without global warming. The Met Office issues extreme heat warnings as part of the weather forecast so that people can be prepared, take precautions and keep an eye out for vulnerable people. With heatwave temperatures, illness and death can occur among the fit and healthy, not just the high-risk groups. On this map, which shows the area affected by the heat warning, you can see the impact the sea has. As the water heats up and cools down more slowly than land, in hot periods the air near water tends to be cooler, and you can also see the effect of hills. The Pennines kept the area between Manchester and York cooler. By 2100, the UK could see 40 degrees every 3 to 4 years, unless we as a global community take very rapid action to limit the amount of greenhouse gases in the atmosphere. The heatwave plan for England aims to prepare for, alert people to and prevent the major avoidable effects on health during periods of severe heat in England. It recommends a series of steps to reduce the risks to health from prolonged exposure to severe heat for 1. The NHS, local authorities, social care and other public agencies. 2. Professionals working with people at risk. And 3. Individuals, local communities and voluntary groups. In this sea level rise graphic here, sea level rise by 2100 is shown for 4 cities, with a low, shown in blue, and a high, shown in orange, greenhouse gas emission scenario. Sea level rises will be higher with higher emissions. The sea level rise will not be the same in all locations and is generally greater in the south than the north because of the impact of isostatic rebound. The fact that Scotland is still rising as it recovers from the weight of the ice sheets which covered it during the last glacial period. As Scotland rises, the UK pivots and the south sinks, compounding sea level rise there. Uplift rates in Scotland are modest, no more than 0.6 millimetres a year. At the same time, coastal waters around the UK are rising at rates of up to 2 millimetres per year. There are a number of diagrams out there that show the risks and opportunities from climate change in the UK. This one here indicates that there could be an opportunity in the tourism and outdoor activity sector due to rising sea levels. The various hazards combine to have an impact on specific industries and activities. For example, Farmers Weekly reported that the hot, dry weather in 2018 led to the UK wheat fields being 6% down on the 5-year average. This was compounded by the fact that the drought was long-lasting and widespread across Europe, leading to high wheat prices. The summer was preceded by a cold, wet spring, during which livestock were kept inside for longer, requiring more food. It became too hot for them in the summer, so they were moved back inside after only a short period of grazing outside. Therefore, their feed, hay and silage, was in short supply and also became very expensive. In the UK, one example of adaptation is coastal flood defences to protect coastal communities from storm surges, whether that's planned upgrades to the Thames Barrier or the smaller barrages which are being built along the east coast. Steart Marsh in Somerset provides flood defences for local homes and businesses and is home to a thriving nature reserve. It is an example of a managed retreat and an example of working with nature to combat the challenges of rising sea levels and more frequent violent winter storms. In a report published in 2022, scientists at the London School of Economics predicted that under current policies, the total cost of climate change damages to the UK are projected to increase from 1.1% of GDP at present to 3.3% by 2050 and 7.4% by 2100. In comparison, a net zero transition is estimated to cost a maximum of 2% of UK GDP. The UK Government established an independent statutory board, the Committee on Climate Change, or the CCC, under the Climate Change Act of 2008. The CCC provides independent analysis and advice and tracks progress towards policy goals. It also publishes a UK-wide climate change risk assessment every 5 years that assesses the risks from current and predicted climate change. The 2022 UK Climate Change Risk Assessment said, 1. Even if the Paris goals are achieved, large economic costs of climate change in the UK over the next 20 years can only be reduced with adaptation. 2. The UK already experiences large economic costs from climate extremes, and these are growing. 3. Unless we take further action, under a 2 degrees Celsius by 2100 warming scenario, annual damages from flooding for non-residential properties across the UK are expected to increase by 27% by 2050 and 40% by 2080. 4. The UK Government recognises there are many barriers to effective adaptation that we must overcome. These include limitations in information awareness of climate risk, lack of clarity on ownership of risk and responses, and the complexity of adapting for a future which contains innate uncertainty. 5. The report highlights the international nature of many climate risks, which can cause cascading effects across borders and sectors with significant impacts on the UK. We have a national adaptation programme created in 2018 which focuses on natural environment, biosecurity, water quality, flood management, soil protection and many others. The UK has a target of being net zero by 2050, but many organisations and businesses have more optimistic targets. There are some great websites which let you monitor the UK energy mix, even advising you on when the green times are to put the oven on. One to note is shouldibake.com. The UK is an Annex 1 country, a term that we explained in Chapter 12, and submits an annual inventory of its greenhouse gas emissions to the UNFCCC, as well as providing information on emissions and removals of greenhouse gases, national circumstances, policies and measures, vulnerability assessment, financial resources, and transfer of technology, education, training, and public awareness. In a biannual report, Annex 1 countries also provide information about their provisions of financial, technological and capability building support to non-Annex 1 parties. As part of its commitments to the Paris Agreement, the UK also has to report on its Action for Climate Empowerment, ACE, which includes climate education. The 2022 DfE Climate Change and Sustainability Education Strategy relates to this commitment. It is clear that teaching about climate change and the scientific facts and evidence behind this does not constitute teaching about political issues, and schools do not need to present misinformation or unsubstantiated claims to provide balance. In the UK, some of our mitigation success stories include the transmission from coal and oil-fired power stations to wind energy, the really rapid take-up of electric cars, and the fact that people are, on average, eating less meat. In addition to this, it was announced at COP29 in 2024 that climate literacy or environmental literacy will be included as part of the Programme for International Student Assessment, or PISA, from 2029. PISA measures 15-year-olds' abilities to use their reading, mathematics and science knowledge and skills, so climate literacy will now be the new addition. There are many sources that look at UK climate. Some of the links have been included in the text below. In the next video, we'll be looking at the climate crisis.